Hello Year 12 and welcome to our third video here on series and sequences. In our last video you might remember we looked at arithmetic sequences and they're sequences that have consecutive terms with a common difference. Okay, from one term to the next I add or subtract the same number. Today we're going to look at geometric sequences. And geometric sequences have a similar sort of pattern, except instead of having a common difference, we have a common ratio. So to get from one term to the next, we multiply by the same number each time. Right? That means we have a common ratio, or if you like, T2 over T1, T2 divided by T1 equals T3 divided by T2 equals T4 divided by T3, and so on. Okay, a common ratio which we abbreviate to R. Let's look at an example here. We want to list the first four terms of a GP, right? Geometric progression or geometric sequence, where A equals 3 and R, our common ratio, equals 2. So if we begin with 3, that's our first term, A equals 3, so my T1 equals 3. And then to get my second term, T2, we multiply by 2. And I multiply that by 2, and by 2 again, and multiply by 2 again. Okay, this is a GP. They don't have a common difference, those terms, right? They have a common ratio, right? 6 divided by 3 is the same as 12 divided by 6 is the same as 24 divided by 12, so on. Right, I said the first four terms, I've done 5. Ah, well, the first four are there, aren't they? Anyway, now to calculate the nth term, right? Simple enough, it's A times R to the n minus 1. Okay, it's not AR to the power of n, okay, because we begin with the first term. So again, it's how many times have I multiplied by R? I've multiplied by R n minus 1 times. I'm sure we've got another example here. Righto, let's calculate the 8th term of a GP with A equals 7 and R equals 10. So it's going to be 7 times 10 to the power of n minus 1, which is 8 minus 1, which is 7. So it's 7 times 10 to the power of 7, which is 70 million, right here. That's the 8th term of that sequence. Now, it's a bit trickier. If GP has T1 equals 10 and T4 equals 3,430, what is the value of T5? Well, T1 is the same as A, so we know that. A equals 10. We also know that T4 equals 3,430, and also we can calculate T4 because it is A, which is 10, times R to the power of n minus 1. So those two things are equal, which means that, right, 10R cubed equals 3,430, or R cubed equals 343. Or if we like, that must mean that R equals 7, right, the cube root of 343. Now we know what A is, we know what R is, easy enough to calculate T5, our 5th term. So let's use our formula. It's 10, right, A is 10, times R to the power of n minus 1, right, I want to find T5, so it's 7 to the power of 4, 1 less than that. 10 times 7 to the 4 is 24,010, I hope, probably. Okay, so that's how we find the nth term of a GP. Don't worry too much about remembering those formulas, doesn't hurt if you do, but they are on your reference sheet. Now, just something to think about here. I'm not going to work through these. We'll get to these sorts of ideas later on in this series of videos. But what do you suppose happens to a GP if R is less than 0? If R is a negative number, what happens if I keep multiplying by a negative number? Also, something to think about. Think about this. If the absolute value of R is less than 1, by which I really mean R is a small number. R is between -1 and 1. Mostly, actually, probably between 0 and 1 is quite an interesting case. What happens if I keep multiplying by a small number over and over again? what happens there. Anyway, something to think about. Those are some ideas we're going to get to later. Consider those. Let's just go back over what we did today. Consecutive terms of a GP have a common ratio, common difference for AP, common ratio for GP. And we calculate the nth term as A times R to the n minus 1. All good. Rightio. Our next video, solving problems about APs and GPs. Rightio. See you then. If you've got any questions, make sure you ask in class. See you then.